Okay, falling film reactor, there are the drawback in which surface area increase kalau perimeter of gas liquid interface increase. Volume also increase as the cross-sectional increase. So bila reactor has large size, the efficiency of falling film reactor will be less. Kalau nak design efficient falling film reactor, maybe it has to be equipped with small tubes in parallel to the large interfacial area. Tapi keadaannya adalah agak sukar and it's not practical. So to overcome the drawback for falling film reactor, engineer design bubble column reactors. So because in bubble column reactors, high interfacial area can be accomplished with rising bubbles or falling drops. So kita dari segi ni dia akan digunakan bubble column or spray tower. Okay, so yang ini bubble column, yang ini spray tower. Perbezaannya, this sparger will produce these bubbles, and yang ini perbezaannya pun yang kat sparger ni dia akan menghasilkan liquid drops. Okay, when and how bubble column reactor works. So usually it used for reaction where gas liquid is low compared to the mass transfer rate. And it is widely used in oxidation, hydrogenation and alkylation process. So kalau bubble column, gas bubbles introduced at the bottom here using sparger. And the bubbles will rise. Why? Of course lah, because bubbles is very light, right? Compared to the liquid. Okay, contohnya gas kita masuk, it's sparged by this sparger. And then for example, this liquid in, and this liquid has a contaminant, for example. And then a reaction happens between liquid and gas. And liquid yang keluar ni akan menjadi yang the pure one, withdrawn at the bottom. So this slide just showing you the concentration profile for reactant A. Example for bubble column or spray tower. So kalau yang ini, the A may be in gas phase and is going to migrate from gas phase into liquid. So kalau yang ini pula, A is maybe in liquid. Sorry, A is still in gas phase, but it's going to migrate to droplet of liquid in order to react, for example. Okay, so bubble columns rely on nozzles, mixing plates, and impellers within the reactor to control its sizes. So kita secara teorinya, for bubble phase volume occupy a fraction, which is volume of gas. So kalau dia beri volume of reactor, so the fraction void of gas epsilon here times volume of reactor or volume of fluid, something like that. Because it has in previous slide, you have to check it on your own. And then volume of each bubble. This one follows the sphere punya theory. And then assume that all particles have the same size. So ini adalah mass transfer rate with concentration gradient, which is this is the same with in previous slide also. A times density and then dz over dt, something like that. Okay, so you can use this equation. Okay, ini pula adalah contoh for falling film with catalytic wall reactor. It's the same as falling film reactor, it's just that there is catalyst on this wall. So basically the catalyst, of course, it will accelerate the reactions in which if A migrate from gas phase to liquid in order to the reaction happens, it will accelerate the reactions to happen. So lepas ni saya akan tunjukkan contoh-contoh macam mana nak kira bubble column and falling film dan juga contoh-contoh yang lain. So bear with me with other videos.